Have you ever looked up at the sky and wondered how thousands of planes are flying around, all at once without it being total chaos? Well, it all comes down to a kind of secret language, a code that keeps the entire system running safely. And today, we're going to crack that code.
So, imagine for a second you're a pilot. You're just minutes from taking off, and this message pops up. To most people, it's complete gibberish, but for you, it's a critical piece of information that could change your entire flight. It's short, it's cryptic, and you absolutely cannot ignore it.
So, what does it actually mean? Well, understanding this isn't just a nice-to-have. It's a fundamental skill that keeps the entire global aviation network running like clockwork. So let's break down the system behind these codes.
Okay, just a quick heads up before we really dive in. This is all for educational and informational purposes. When it comes to the real world of flying, you always refer to the official documentation. All right, let's get to it. First things first. Every single flight operation has to happen somewhere. So our first set of codes is all about defining the where, from a single runway all the way up to an entire continent. This is our operational map.
So let's start with ADR, which stands for aerodrome. You can just think of this as the "you are here" pin on our map. It could be a massive international airport or a tiny little grass strip in the middle of nowhere. It's the most basic starting point for everything we're going to talk about.
Now let's zoom way out. From that one little aerodrome, we can zoom out to a massive area like AFI, the Africa Indian Ocean region. See, the whole world is carved up into these huge operational zones by ICAO. That's the International Civil Aviation Organization. And why does that matter? Because the rules of the game, the procedures, the communication, all of it can literally change the second you fly across one of these invisible lines in the sky. Okay, so we've got our map. We know where things are happening. Now, how do we find out the rules for operating on that map? Well, this next layer is all about the official documents and services that give pilots the information they absolutely need to have. These are the rulebooks.
And the most important rulebook of all is the AIP, the Aeronautical Information Publication. This thing is basically the Bible for flying in any given country. It has every single detail you could ever need, from how long the runways are to very specific local procedures. If you're flying there, you'd better have done your homework and read the AIP.
Now, down on the ground, at some airports, you'll find something called AFIS. That's the Aerodrome Flight Information Service. Think of them as the helpful voice on the radio, giving you the latest updates on the weather, who else is flying around, and what the runway conditions are like. But there's a really key thing to remember about them.
And here's the difference in a nutshell. AFIS gives you information. They give you advice. Air Traffic Control, or ATC, gives you commands. They have control. It's a hugely important distinction. One is a helpful guide, the other is the boss. You listen to AFIS, but you obey ATC. All right, so we have our map and we have our rulebooks, but aviation isn't static, right? It's a living, breathing system that's happening in real time. This next part is all about the network that makes that possible. The system that carries all this information and brings the whole thing to life. The engine that drives this whole live network is the AFS, the Aeronautical Fixed Service. Now, this isn't something a pilot uses directly in the cockpit, but it's the invisible backbone that makes their job possible. It's basically the private internet for aviation, a global network carrying everything from flight plans to weather reports to, you guessed it, our cryptic little messages. Let me make that real for you. So, a dispatcher files a flight plan. Instantly, that little data packet gets blasted across the AFS network to every single air traffic control unit and airport that's on the route. It's this invisible web that makes sure everyone who needs to know about a flight knows about it, way before the plane even pushes back from the gate. And speaking of pushing back, that brings us to ADT, the actual departure time. Now, this is not the time on your ticket. This is the exact real-time moment the aircraft physically goes off blocks and starts to move. This is the moment the plan turns into reality, and it's an absolutely critical piece of data for the whole system. So why is this one little number so important? Because the entire live network runs on it. It's the key to tracking aircraft in real time, to coordinating takeoffs and landings across the country, and for figuring out exactly why and where delays are happening. You see, the schedule is just a plan. The ADT is what actually happened. So, we've laid out our map, we've opened the rulebooks, and we've plugged into the live network. Now we finally have all the tools we need to go back and decode that original message. This is the payoff. Let's see it in action. Here it is again, that short, cryptic, but really important message. Now, armed with everything we've just learned, what looked like a bunch of random letters is about to become perfectly clear.
So what is this really saying? AIP updated. Well, that means the official rulebook, the Aeronautical Information Publication, has a permanent change. Refer to AIC, that's an Aeronautical Information Circular. It's telling the pilot, hey, go look at this advisory notice for the details. And ATC procedures revised? That's pretty straightforward. It means the specific rules for how you talk to air traffic control have changed. And just like that, the code becomes a clear, simple instruction.
And that right there is the whole philosophy. This language isn't just about saving a few characters. It's about creating a way of communicating that is short, incredibly precise, and understood by everyone, everywhere. Whether you're in a control tower in Tokyo or in a cockpit over the Atlantic, it's a system built to get rid of any confusion in a world where confusion can be dangerous.
It's a pretty powerful idea, right? That these massive, complex systems are often running on simple, elegant codes that are hidden in plain sight. It really makes you wonder, what other invisible languages are out there right now, humming along in the background, quietly keeping our entire world in motion?